Hello, everyone. Welcome back to the It's a Material World podcast. I'm your host, Puneeth. I got my co-host, David, alongside me. How's it going, David? What's new in your world?
I'm doing great. My school semester is just about finished up, and I moved into a new apartment. So I have a new background, so check us out on YouTube to see my blank wall. Um, but other than that, it's just been busy moving and finishing school. What's up with you?
Yeah, I also have a blank wall background. So twins in that regard. I also moved this past weekend. It was pretty stressful because it was just like a quick turnaround with my lease ending yesterday. And then it was just like a bunch of back and forth. Had to figure out how to rent and drive a U-Haul. So that was a process in and of itself to kind of move like the big stuff like the mattress and couches and stuff. So it was more stressful than I imagined, but we got there and I'm feeling more and more at home with each day. And speaking of home, the topic of our conversation kind of revolves around like the construction industry, namely like timber-based biocomposites to disrupt the construction industry. So what was your favorite part of the episode that you think our listeners should look forward to?
Yeah, I think that one thing that I've learned through all my experiences is that even though that you can talk about wood and something that you think is kind of antiquated and old, there's cutting edge technology that is being implemented here in the form of automation and robotics that is very similar to other areas of the world, and it just shows how the entire population, like manufacturing wise, is growing, and it's enabling all these new technologies which allow us to rethink how we construct, build, and produce goods that we use every day. And so that was my favorite part. What was yours?
Yeah, it was like along the same lines where it was just how do you catch up with the current technologies that had refined processes for decades, right? Like in this case, concrete, steel, aluminum, very efficient at this point. So how in just a few years can you catch up to the point where you can replace some of those incumbent materials? That was a fascinating conversation. And then also like our guest, Jorge, has a very diverse background, robotics, architecture, composites. It's really all over the place. He even dabbled in music. So it's just kind of cool to see his advice for us MSEs where we can explore a lot of different paths. So just hearing his story is something that I would look forward to because it shows that like it's not a waste to try out something new. There's a lot of innovation that can happen when you're at the intersection of multiple disciplines. So yeah, look forward to that in the episode. And make sure to leave us a rating and review on Spotify and Apple and subscribe to us on YouTube. We're closing in on 1,000 subscribers. So that would really help us out. All right, let's get into the episode.
Our sponsor today is Johnson Matthey. Are you a material scientist or engineer who wants to be part of the drive for a world that is healthy and cleaner, both for today and for future generations? By understanding the relationship between a material structure and its physical properties and chemical behavior, material scientists and engineers at Johnson Matthey develop sustainable technologies that are catalyzing the zero transition in transport, chemicals, and energy. They design porous materials for catalyst supports for emission control systems that remove harmful emissions produced by diesel and gasoline engines. They innovate new compositions for catalysts at the heart of the hydrogen fuel cells in trucks and buses. And they also develop new corrosion-resistant reactors for processes that enable the production of sustainable chemicals and fuels. To find out more, visit matthey.com. That's MATTHEY.com. Johnson Matthey, inspiring science, enhancing life.
Hey everyone, we are super excited to welcome today's guest, Jorge Christie, CTO and founder of Strong by Form. Jorge has a very diverse background, which includes being a certified robot programmer, a principal architect, and holding multiple master's degrees. At Strong by Form, he is creating technologies to help us develop with the environment, not against it, by creating sustainable ultralight, high performance, timber based biocomposites to potentially replace steel, aluminum, and concrete in construction and mobility. Thank you so much for joining us today, Jorge. We are very excited to have you on the show.
Thank you guys for the invitation. I'm also super excited to be here and looking forward for our conversation.
So yeah, I think our first question is just, it's first hard to make change in any industry, but then another level of added difficulty is that you wanted to start your own business, and that's a serious undertaking. So we wanted to know what inspired you to be an entrepreneur and start Strong by Form.
I would say the answer is not super straightforward because it wasn't really on my original plan. Maybe I should go back to my studies. I was making my master's in the University of Stuttgart, where I was developing a method for optimizing carbon fiber structures based on form optimization and fiber optimization. And I had this idea that, carbon fiber is a pretty energy and CO2 intensive material. So I thought, how could I bring all what I've learned into a more sustainable material? And that's how I started talking to one of my future partners about this idea. Is one of my intellectual sparring that I use for ping pong ideas. And he said, okay, why don't we actually, I think what you described is super cool. I think we could do it. Why don't we just start a company with this? And then it was like, okay, maybe let's talk with this other friend who is more involved with innovation. And suddenly, after a big back and forth, we decided to apply to a fund to say, okay, maybe we organize our ideas about this technology based on wood and with the optimized structures. And what happened is that we applied for this fund and we got it. So basically, at some point, we were forced to be a company and to start. It was like a point that when, okay, we have all this money, we either take it or we don't take it. We go for this or we don't, and we decided, okay, let's give it a try. And here we are, like 3 years later, with the company actually doing quite well for the initial state. But that's how it started. So it wasn't really that I was thinking on going into business. It was more like I was thinking on new technologies, and I met the right people to bring those ideas into a business idea. That's more or less how it happened.
What was it like taking that leap of faith where you said, we have all this money, we either do it or we don't do it? What was that like?
I believe a lot on this idea. So I really think that the way we've been building with wood so far up to today is pretty, let's call it primitive in a certain sense. I have a lot of admirations for carpenters. I know what they do, but the processing of the wood and the thinking of the wood, it's pretty old school. We thought on bringing this idea of composite logic into wood and kind of creating our own wood or shaping our own wood to our materials. So I would say it was like I was really curious to know how this could work. I had like the knowledge to do it. I had a clear idea how to do it, but I didn't know if it could work. So it was like more, okay, we have the chance that one comes once in a while for having funds for actually exploring and doing R&D, not in university context, but in the business context, which was a really cool opportunity, because normally when you do R&D in academia, you're not thinking so much on how it's going to be the outcome, how we're going to sell this stuff, who wants this stuff. It's more like, okay, this hasn't been tackled before, so we will tackle it. But in business, you have to do novel stuff, but they have to be also someone must want it, and someone must be willing to pay for it. And so that was super interesting to me. I come from our academic background and research background, and this opportunity was really, really unique of saying, okay, how we can cross these two worlds, how we can influence research with business development. So
I'm curious, what was it like to pitch to potential investors, given your like academic background? Because from what I've heard, they want to know that they're investing in the right people first and foremost, but then also they want to know that it's a viable business option, that there's demand for it. So what was it like to create that pitch?
It was a good journey, especially for me that I don't come from this business kind of background. I mean, I'm based in Germany, by the way, but my two partners are based in Chile. So since the beginning, we have this double address, Chile, Germany. And here we entered in a acceleration program in Germany. And it was good in the sense that it gave us some framework, but at the same time, it was quite disappointing in the sense that Germany, as you might know, is a pretty industrialized country, but it doesn't come from the culture of startups. Germany comes from the business, from the family business perspective. So I think they still evaluate business from that perspective. So if you don't have sales, if you don't have profit, if you don't have your first client, basically you don't exist. So for us, it was kind of, yeah, it was kind of shocking to see that, okay, this is might not be the right environment. And actually our first founding and our first investors came from Chile. So what it was interesting is that by pitching our ideas in more like public events, we got the attention from some corporates from the timber world. And that was really, really cool because it was like established huge companies that they were like seeing all this startup scene kind of flourishing, and they kind of getting a bit behind of that. So they wanted to innovate and they wanted to kind of bring fresh air. So that was the way we could build a bridge between our kind of dreamy ideas on how to rethink wood and getting some funds to start more on the private side to make things move. Yeah, and at the same time, we've been always combining private funding with public funding. So we do a lot of R&D based on public funding, and we've been kind of quite successful getting some public funds for R&D.
That's awesome. Okay, so now, I mean, you've mentioned timber and just changing the way we think about like the wood industry. So can you explain now like your core technology at Strong by Form and how it differs from traditional technologies in this space?
Let's maybe start from what is wood technologies. So mostly wood technologies, they inherit all what the products are from the logic of timber sawmills. So you have a tree that you saw into different parts, and then you sell those parts. Let's say that's the origin of it. And then you assemble those parts and you make larger parts and you make a house or whatever, a bridge, whatever you need to do. So it's this logic of transforming wood into kind of prisms and kind of prismatic volumes that you then chop, and drill, and then combine into larger parts. That's, let's say, timber, carpentry, construction, and so on. So after my experience with carbon fiber, I thought that actually, yeah, wood is a natural composite. It's fibers with lignin and so on and so forth. So it is actually a fiber reinforced composite on itself. So you could actually bring all the logic of composites, of advanced composites like carbon fiber or glass fiber or whatever, into wood. So that was a little bit the two worlds that we wanted to cross. So what we do, it's actually, my background is in computational design, robotics, and technology integration. And so what we design, it was like it is like a unified or integrated workflow that goes from the material itself and how you actually process the material up to the final part. And for building that bridge, like from the raw material to the final part, what we do is we have a couple of software that can, first you analyze the material properties of your formulation. Then we perform shape optimization, which is something that normally you wouldn't do with wood. It's more like from aerospace or car manufacturing, this optimization methods. We perform also fiber optimization within the software. And then we connect this analysis and optimization software to our own manufacturing facilities that can read all this information and turn it into a map of fibers that then we press into a shape. So that's roughly, let's say, the schematics of that technology. Yeah. So what is interesting about what we do is that we actually need a little bit of everything, a little bit of material science, a little bit of computational optimization, a little bit of controlling and machines and a little bit of everything in all this part. And what is cool and what is enabled by computation is that all this thing is integrated. So we have control of every single strand of wood in our composites. Maybe I should also say that what we do is based on wood strands. So that's the way we work with wood. Wood strands is what is interesting of wood strands is that it's the most efficient way of working with wood. So if you turn a tree into planks for construction, you might use 40 to 60% of the tree for structural purposes. If you do veneer, you might use up to 70% of the tree roughly. And if you do stranding of the same tree, you might use up to 90% of the tree. So what is interesting is that you can use the whole tree, or almost the whole tree, except for the branches and the bark, but then you can just start with the branches and the bark. And also because we have this ability of optimizing the fiber orientation, and because it's strand-based, we can do freeform. And freeform enables like a huge scope of design and optimization and efficiency that has never been on the reach of wood. So that's the two worlds we want to bridge, let's say the traditional material of wood, but we actually don't use almost anything of the tradition of carpentry, but we bring more, or we nourish more from the world of composites and optimization logics, kind of fiber orientation and all the stuff, and automated fabrication that comes from that world. So that's, let's say, our main jump.
What do you mean by freeform?
I mean forms that are not, in this case, constrained by the form of the original material. For example, if you do a roof on timber, you might use like linear elements that you then assemble, you make like a truss, and then you repeat it, and then you have a kind of roof structure. What we can do instead is we can actually shape a surface to have all the form needed to resist the loads, but also to eventually integrate different services on it. So freeform is not that you can do any shape, because our process has some limitations derived especially from the pressing part of the process. But you can actually shape a part. It's more like what you do in car manufacturing when you do metal stamping. It's that you turn a flat sheet into a specific form that is resisting by form. So it's basically the same approach.
So a few questions. The first one is, with this freeform approach, what is the size of like shapes or actual like structures that you could create in your process? Is there a limit, or could it be limitless given a big enough machine?
I would say the size of the part is the size of the press. There are larger or smaller presses, but at the same time, you can combine them. Same thing with car manufacturing. When you do a car, you don't stamp a car with one shot. It's like you're combining different parts. You are, in this case, welding them when this metal, in our case, might be gluing them to make more complex structures. So yeah, in theory, it's limitless. We haven't really gone through the adventure of making like a 30-meter part may assemble out of smaller parts, but in theory it should be feasible.
And when you are going through what Strong by Form does, it seems you focus a lot about getting data at each step of the way. I think that's how manufacturing is progressing at today's standard. I think when you talk about wood, when you think about like just creating planks, and now you're talking about a complete restructuring of how we process it, it's like a huge comparison. But if we look at the overall trend, what do you think this will enable in like 10 years when manufacturing is heading in this direction of getting data at each step of the way to make more optimized decision making?
As you would say, for us, data is key in all this process. And that's a little bit like the big change we're making into wood. It's like you have all this data. For example, we are using computer vision for keeping track on each strand on our structure, so we can actually have an assessment on the quality of our parts up to the strand level. And we are well aware that the integration of all this data is what might bring the efficiency on all this process. So Construction is one of the more delays industry in terms of industrialization, prefabrication, and manufacturing. It is really like since 20 years stuck on the same productivity. So we see the integration of the whole value chain, like from the material to the final part, as the game changer here for improved productivity. So that's a little bit what we see as the big change in the future. We are, again, following trends that are way more familiar in the world of automotive production, for example, rather than in building construction. But there is many companies that are already actually are tackling the same problem of building houses, let's say, closer to how you do cars. The main difference with other companies is that we are starting not from the board and the plank of wood, but we are starting actually from the material itself. So we are creating our own material formulations. We are specifying what's the size of the particles, what's the relation with the adhesive, how many other additives you want to add, so we can tune up the formulations for specific applications. So that's how we see the whole change.
So, and then my question is, so the goal of this like core technology is potentially to like make an impact in the construction industry, for example, right? And to potentially replace the more common materials that are used in this industry currently. So, but like with those materials, it's like steel and aluminum, where it's like very refined processes over decades. So I was just wondering, what are the advantages that these timber-based biocomposites provide in the construction mobility industry, and maybe what are the challenges that we still need to overcome, because you're catching up on decades of process optimization, and with that comes costs too, right?
Yeah. Well, there you're totally right. We are competing with technologies that have, somehow destinies of developments and decades of developments, and then we come up with this new stuff, and we need to kind of catch up with everything in a really short time. And that's a bit of the challenge of any new technology that kind of brings a new process into the game. The cool thing, or why we think we might be competitive and why we are optimistic about this, is because of the environmental crisis. So the way we've been building so far until today, it is pretty not environmentally friendly. Concrete, that is the main material we use, is depleting the sands reservoirs. It is super intense on CO2 emissions. And if we don't rethink the way we even build with concrete, we will have problems. We are already having problems, so we have even more complicated problems in the future. Same thing with wood. There's a really interesting trend today into moving towards wood construction, at least in construction industry. But what happened is that we are making the same mistake we did with concrete, again with wood. So we are building buildings that are massively using, they are using the material performance based on the massivity of the material. So you have huge columns with huge slabs, all like just solid wood. And that to me is not the most smart way to use such a precious material as wood. So where we think we can contribute is by actually offering the same performance that today's concrete can do and timber can do, using a fraction of a very sustainable material. So so we can actually enable the trend of wood construction to keep growing without harming the environment. So that's a little bit the trade-off. It's like we want to actually support the expansion of wood in construction, but we see that the way we are building today, it's not sustainable in the long term, because we're using the material in a very dumb way. Or, you know, it's like there is other factors that put pressure on construction, and mostly is speed of construction or the availability or the easiness. But as we see the growing concerns in environmental protection, polluting or harming the environment, it's not going to be for free in the future. So there is also a competitive edge when you have a sustainable technology that is capable of delivering similar structural performance with a fraction of the material, and also when that material is sustainable source, it is renewable, is capturing CO2 emissions, and so on and so forth. So I think that's a little bit the game we are on.
And so, taking a step back, it sounds like you take a lot of inspiration from nature in everything you do, and especially with all this processing. For some of our listeners who are not used to solving engineering problems and looking at these natural processes, could you describe the benefits and how that's helping you create this process to overcome the incumbent materials in the space?
Maybe we start with a tree, or maybe no, I guess everyone has seen a tree, but not everyone has cut a tree and analyzed the tree, how it goes inside. So basically, a tree is a bunch of fibers that are bundled together, and they are kind of surrounded by fibers that they are keeping those bundle of fibers in place. So it's like if you take like a sushi mat and you roll it, that's basically a trunk of a tree. So you have fibers growing primarily in one direction, and you have secondary fibers kind of wrapping all this thing up to prevent the buckling of the structure. And then when it branches, actually the form changes and the fiber orientation actually changes as well. So basically, in structural terms, what the tree is doing is doing some cantilevering structures that are the branches, and it's optimizing the fiber orientation to actually resist bending on the branches and wind on the trunk and so on and so forth. So this optimization of form and fiber orientation is what we reproduce in our process. And it's in a very high level term. So it's not that we do a biomimetic, like saying, okay, this species of trees do this thing in this way, but it's more at a higher level in the sense that, okay, this is just a combination of optimization processes with the material that the tree has available and the formulation that the tree by natural selection evolved into its own structure, and then is producing compression wood or tension wood, and so on and so forth. So what we do is bringing that into the engineering timber world. And I think that, again, like the leap we do is that we don't think in commodities, we don't think in boards and plank, but we think on final parts. And so when you do have the final design, you can say, okay, the flow, the stresses will flow this way, so we need to actually orient the fibers this way. But actually, if the form can be double curve in this way, it will be more resistant to buckling in this area, blah blah blah. And so that's all the process what we do. So we try to bring that knowledge into engineering wood, again, as a very high level reference. It's not again a single species or a single molecule or whatever, but it's more again like principles. And I think when we bring principles, we are a bit more flexible on the applications of the design, and the principle is still valid.
Interesting. So then what advice would you give to, I guess, like the next generation of material scientists when it comes to potentially like thinking about those first principles and even looking at nature to inspire future innovations? I know that's very dependent on the industry, but was just wondering what your thoughts were there.
Actually, I think material science so far is what we've been tackling the more basic, on a more basic way. We think actually there is so much more space to grow in our own technology by refining and adding, I don't know, processes to the fibers, additives, bio binders, activating the chemistry of the wood, and so on and so forth. That I think we have a process that is from the material science upwards that is kind of clear, and there is this more mechanistic way of assembling the materials. But when you go on the material side backwards, there's again like a huge world of explorations that you can do. So I'm not a material scientist, so I couldn't give any advice to material scientists. But what I can say is that material science is extremely valuable when you want to add value to materials like ours. Again, I have a little bit of knowledge, but a material science might come with a new formulation for whatever process or activating something that is already on the wood. new glues or working with fibers themselves to process them in a different way, so you have more flexibility or more whatever, more workability, being sensible to pressure. I don't know, it's endless. So I think what is beautiful of material science is a little bit like reproducing nature, in a sense that it's playing around with a bunch of materials, with a bunch of of basic ingredients into new formulations that they have new properties. They are always more sustainable. They are recyclable, compostable, whatever. That my advice is like there is so much space today for new materials. We need to replace all our materials, because all our materials are until the 20th century. They were valid because we were just polluting and not actually thinking much about it. But when you have scarcity, you have new guidelines, and you need to actually be extremely creative in how this new material is going to be. So I don't know what to say to material scientists. So I can only say that material science is great. And there's plenty of opportunities to reinvent future materials through going into looking at that scale. Then other guys like us or like other companies can take those materials and turn them into products, but we need the input from material scientists.
Yeah, I agree. Material science is great, and it's cool to see it disrupting this industry where, like you were saying, there's just a lot of room for growth, and some of the processes might be outdated. And so I want to get back to that core technology a little bit and shift to something that we haven't really shed enough light on, which is kind of the 3D printing aspect of it, and just being able to 3D print composite materials with the same structural capacity of wood. And so I was wondering if you could go into that process and also maybe share like what is the difference between this process and what we're seeing in today's technologies?
Our technology is additive manufacturing based, and it's not 3D printing, has nothing to do with 3D printing, actually, as you might know it, like fuse deposition modeling or similar stuff, but it is an additive manufacturing. I cannot say all the things because there's some stuff that are secret, so we cannot actually disclose them here. But what is cool about additive manufacturing is that actually you can tune up your own materials. You can tune up your own fiber orientation. You use less raw material because you just print what you need. In our case, we trim a little bit the excess, but in general, compared with other processes, when you have a board and you just mill out a special form, you have so much leftovers. So that's the cool thing of additive manufacturing. How it differs from current processes. There's a lot of additive manufacturing in the timber industry, but for producing commodities, again, for producing sticks and for producing boards. And then what happens is that then you have to take those boards and sticks to make parts and elements, and then you cut them and you have leftovers, and it's not the most efficient process. What additive manufacturing enables at this scale, so where you have control, is to actually reduce a lot the waste that you're producing and just use the material that you need. We do this with robotics because we have a lot of control over, by using robotics, you have a lot of control over the positioning of parts, of elements and fibers and so on. So you can achieve like a high degree of control over the performance of the final part. And that's what we aim for when you aim for a high performance.
And so when you talk about this, it sounds like you're adding a lot of new variables. And so you have additive manufacturing and restructuring. It gives you a lot more control over the final properties. And so the main issue with wood in buildings is its weakness to fire, decay, affected by weather, etc. So with this extra control that you're now embedding in your technology, are there ways that we can overcome these inherent flaws in this building material?
Well, what we do is actually our material is 90% wood. So most of the problems and the properties of the wood are inherited to our parts. What is interesting of working with material formulations in comparison to a stick or a sawwood is that you can actually add some additives to the formulation, or pre-treat the wood, or add additives to the binder, or post-treat the elements, so you can actually overcome a little bit part of these problems. One of the challenges you have here, and what that's one of the challenges we are facing today, is that all the industry is used to 20th century's materials like steel or aluminum, that they are made for lasting extremely long time, well, depending on the weather conditions and so on and so forth. So all the regulations today are forcing you to have materials that don't decay. But on the other hand, you want to make materials that are compostable, because you don't want to create trash, right? So this trade-off between being sustainable in a true way, in producing things that are not going to be harmful again if you put them back into the environment, and on the other hand, the norms that are actually forcing you to make your products to last for at least 20 years anywhere where you put them, it is somehow contradictory to me. But we won't change. We're not here to change the rules. We are a small company trying to make stuff. But there is this inherent tension, I think, between the goals of being sustainable and, on the other hand, all what we are used to. We are used to prices. We are used to some kind of comfort. We are used to some kind of decay on the materials. But we want to be sustainable and without changing any of that. That's contradictory, and that's a bit of a tension where we are at the moment. Because if we make a building with a facade system that is made out of material, and we want to make that compostable, that won't last 20 years because it's wood, and wood is made to decay. It's a dead living being, unless you protect it, and there's many other ways, like by architecture, that you can put it under the roof, like ancient temples do, but you cannot do ancient temples everywhere. So yeah, that's a little bit like a tension that I have identified. The cool thing of our approach is that, again, you can tune up the formulation, so you can make it a bit more UV resistant, a bit more fire resistant, but most of that stuff is adding chemistry that is not necessarily nice to the environment. So you have, again, this trade-off between how long do you want it to last, how fireproof you want it to be, and how sustainable you want it to be. And I think that's part of the challenges you guys as material scientists are going to face in the future, to develop fireproofing materials or chemistry that can help, that can be at the same time compostable, and they are not poisonous with whatever for the insects. So I think that that's a beautiful challenge. There are some products out there and there's many groups, there's many groups investigating on this kind of things. So I think in 5 years, we're going to have a whole new pool of new cool products that are bio-based and bio-friendly, with excellent properties. But I think, again, there's a mindset change that it needs to happen at the politician level, and kind of the people who makes the norms, that if you want things to be actually sustainable and actually compostable, and that can bio-integrate well with nature, they won't last forever.
Do you envision, like, I guess in the short term or even in the long term, like a mix of kind of the incumbent materials, steel, aluminum, concrete, and these more sustainable alternatives like this timber-based biocomposite working together for construction? Is that what you envision in the short term? And then what does it look like in the long term? Do you see it fully replacing these current materials?
I think actual materials are great. The problem we have is that we use them too much and for everything, especially concrete. It's some amazing material, but if you start building all the buildings with concrete, with this dumb way to do it, you certainly won't go very far, especially considering all the needs for construction that we have today. So I envision a future, and it's actually happening today, where you actually mingle a little bit the two worlds, but it implies that concrete has to become more sustainable, steel has to become more sustainable, aluminum has to become more sustainable, and also you have to use them where they are key. and where you actually need them and not everywhere. So I don't think we are going to manage to replace all all highly polluting materials by new materials that are zero polluting from one day to the other. But we're going to have a kind of transition like today we have with books and ebooks and like different technologies that target the same content but with different formats. I think it's going to be a little bit the same. And for example, we think what we do, because we can do free form, we could also do foam work for concrete. And so you can actually give to the concrete a more optimized form. So we can use part of what we've learned in optimization, actually, not just to optimize wood, but actually to optimize concrete. And I think, there is plenty of room for optimization in different materials, but you really need to rethink a little bit the whole production chain from the raw material to the final part, as we are trying to do. So I think there's plenty of room for plenty of materials. I don't think any material, I mean, there's places where wood definitely is not sustainable because there's no wood. So it might be more sustainable to be with earth or with, I don't know, with concrete even. So I don't think there's a kind of a magic wand that will come and solve all the problems of the world, but it's more like it has to be sensitive to the local environment, ideally the more locally possible, and also to use the strength of each material on the best use, and not to use one thing for everything, as we've been doing with concrete, for example, using it as insulation, waterproofing, structure, and so on and so forth.
Yeah, for sure. Okay. So now I know we talked about this very early on in the conversation, but it's kind of been a common theme of the idea of like automation, robotics, and then also like architecture inherently, which you have backgrounds in. You have multiple master's degrees and just a very diverse background. So I wanted to touch on that, and I just wanted to ask, like, how useful has your like diversification of backgrounds been in the creation of this company and the development of these materials? Can you like elaborate on that and the impact of automation on these processes?
Okay, I think there's two questions there. One is how a diversity of background can help you in creating new technologies, for example. And I would say in that case, I would say a lot, because you have basically complex problems. You can hardly tackle them with one discipline. I mean, disciplines are artificial separations of humans into specialized knowledge in order to get deeper into that. But actually the problems, they have the full complexity. And so either you assemble a team of people with different skills that can actually talk to each other pretty well, and they have common language, which is one of the main barriers, because you have an engineer talking to an architect, and they don't have the same background, and they don't have the same language, and they don't necessarily understand each other. So to me, what has been interesting of my parkour, I've been involved with art, design, architecture, computation, a bit of robotics, and now I'm really digging into structural optimization. It is that I can see a little bit wider, and maybe it has helped me to see how different disciplines can cross roads, because either you sit on the same table, people from different disciplines, to try to cross road, or you cross the roads inside of your head by having a wider scope of experiences. And I think in my case of this, I came up with this idea by actually being exposed to timber, to robots, to material science, to composites. I took some composite courses in ETH and so on and so forth. And all these things kind of build up in my head and boil up to a point where I was able to imagine these things. So yeah, I believe it's my path, that there's this kind of two approaches. You can be like super specialist, or you can be a generalist. And I think I define myself more as a kind of a sort of a specialized generalist, but I'm a generalist in the sense that I've been doing a lot of different stuff, and I'm curious about everything. And I think this part of this strive for creating new stuff comes from this curiosity for everything. And I believe that a lot of innovation comes from this mindsets of people that can cross disciplinary and borders and doesn't recognize its own barrier, but actually moves kind of freely between biology, psychology, music, and art and engineering, and can actually bring a little bit of all that stuff into what he or she is doing. And yeah, that's at least what I try to do. And I think I'm a late runner. I'm 47. I'm still studying, making my PhD, and I have 20-something classmates. But what has been great to me is that actually all this experience I've been building up within my different studies, has resulted in a I would say more informed way of looking at problems, and more informed, not in the deepness, but not in the depth, but on the breadth. I think that has been really cool. And then the other question is the role of automation and all this. And I think that's a different question. What is cool of robotics and automation is that actually enables you to link the software with the physical reality in a quite precise way. So with robots, you can have super good control of speed, position, orientation, and so on and so forth, that can deal pretty well with the complexity that you can achieve in the computational side. And on the other hand, it can become physical stuff that you can interact with. So what the role of robotics in our company plays is this role of translation from all this digital optimization world into a physical stuff. And that could not be possible without a robot. And also what enables is that actually robotics are cool because you can have high productivity of pretty complex stuff, which is what we do. So when productivity meets tailor, it's a really cool world, and that's where we are. That's where we are actually.
Yeah, I really like that, how basically robotics and automation are enabling us to basically let you rethink how we're going to use timber and other materials in the future. So I think that's very cool. Back to your diverse background, when you're going through college, how did you come across these things that you eventually got your master's in? What was the exploration pattern into your curiosity, and what finally decided you to run down each of those masters?
The other day I was doing a lecture, and I was asked for my parkour, and I had to do a diagram of my parkour, and it was super interesting exercise, because actually my parkour was looking like a tree that was branching in many branches, but all these branches were not like dead end roads. So I was doing I started engineering first, civil engineering, and I wasn't really successful with mathematics, so I moved to architecture. But then I did a bit of music, and then I did, actually not a bit, I was quite into music for some time, and then I did a bit of tailoring. And then I did teaching, and I developed methodologies for teaching. And then I decided to study again, and I started computational design and robotics. That is nothing to do with anything I've done before. So I couldn't advise anyone to do this, because it's really pretty explorative, but at the same time, it can be very frustrating, because you always you arrive to a point where you say, okay, maybe I'm not that good actually at tailoring, so I will come back. But actually, a couple of years later, when you're dealing with complex shapes, understanding how you tailor patterns into three-dimensional parts is super useful. But I was lucky enough to be obsessed with the similar things that, say, throughout my career, that have been slowly converging into what I'm doing today. But I couldn't advise anyone to follow that path. I think it has to come natural to you if you are someone who is curious about different stuff, and then saying, okay, I will just put it aside and I will now focus on this biology thing or whatever. First, you have to have the lack of having the means, because most people just have to work to earn their daily life. I was very happy that by doing teaching, I could finance myself on the basis, so I could actually explore a lot. but not everyone can have this privilege. And then you have to have people around you that supports you, because if you're changing every 5 year your career or whatever, you might not be the most proficient or the best investment. I don't know if you think about investment versus return. In my case, I'm a really bad business, because I've been studying a lot of years in my life. I will have a terrible retirement because I've been studying more than I've been working. But I've had the privilege of doing it, and I think so far to today has been super profitable for what I'm doing today. And I've been very fortunate to be able to actually doing it with a couple of partners that I have, that they complement all what I don't know, and they bring all their knowledge and experience, and making this actually this initial dream into kind of more plausible dream.
Awesome. Yeah, no, that was really great. And I think that the ROI is definitely there, because from what we've heard in previous episodes, there's a lot of innovation that can happen at those boundaries between disciplines, and it seems like you're just setting yourself up for more and more of that, because you're always in between multiple disciplines too. So I think that was a great place to kind of wrap up this episode, and we wanted to thank you for your time, Jorge. This was really insightful, and it was really cool to see the work you all are doing. I'm excited to follow along in your journey.
Great. I'm also very thankful, guys, for giving me the opportunity to talk to you, and to, hopefully having answered some of your doubts or questions or inspirations. And it's a bit weird always to talk about our own parkour, but I hope it has inspired some other people that might feel a bit lost because they like too many things at the same time, to actually pursue them all. But yeah, it was a pleasure to meet you guys, and hopefully, and congratulations for the podcast. I think it's a great thing, and I'm pretty happy that you're having the students in mind when you do all this stuff.
Thank you. It means a lot.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.